You know what an inscribed angle is. It's an angle whose vertex is on the circle. However, it is produced by two chords. Today, we are going to look at angles that are on the circle, but they are made by something other than two chords. So we're going to be able to calculate arc measures formed by a chord and a tangent. We're going to be able to apply the properties of inscribed quadrilaterals. So yesterday, or in the previous lesson, we had inscribed angles, and I'm just going to draw that over here. So an inscribed angle, remember, has a vertex on the circle, but it's made up of chords. Today, our vertex is still going to be on the circle, but instead of two chords, we still have one chord, but then we have a tangent. So there is an angle being formed here, and there is a chord that's in its interior. So it's still a chord arc relation, an angle arc relationship. The really nice thing is, even though this is not an inscribed angle, it has exactly the same relationship as an inscribed angle. So we know that an inscribed angle, the angle itself, so we know that to be theta, and the arc, we know the inscribed angle is half the degree value of the arc. So we know that from yesterday, or whatever day you noticed that last. And this is the same situation here. So let's look at this scenario right here. This angle all the way out to here is called angle 2. So the measure of angle 2 will be half the measure of the arc. So the arc started at B and it went to A. Or it started at A and went to B. It doesn't really matter about the order in that case. But instead of one angle being formed, there are actually two angles being formed. So you will notice there is an angle 1 here as well, and the measure of angle 1 is half of the arc that it cuts. Now that arc goes from A to B as well, but anytime you have two letters, you're really going the shortest possible arc route you can go. So if I just say the measure of arc BA or AB, that's going to take me the short route. I need to go this long route, so I need to mention C. So I'm looking at starting at B, going past C, and then coming down to A. So how's that going to work on a problem? I just need to check to see where the vertex is. Is the vertex in the center, because then it's a central angle, or is it on the circle? Is it either on the circle because it's inscribed, or is it on because I have a chord and a tangent? It's on because I have a chord and a tangent. So this entire angle is 110 degrees. So the angle of 110 degrees is half the measure of the arc, and the arc was x. Multiply both sides by 2, and the measure of the arc ends up being 220 degrees. So this arc is 220 degrees out of the 360. So number 2, here's our angle. So our angle is x, and it is half the measure of the arc. Problem: I don't know this arc. How in the world am I supposed to figure out what that is? Yeah, you're right. An entire circle is 360 degrees. So this arc is 360 degrees minus the 128 that we actually already know. So this arc is 232 degrees. So 2 plus 8 is 10. 3 plus 5 carry 1 is 6. 2 plus 1 is 3. So 232 degrees. So what that means is our angle in degrees x is half of 232 degrees. So x is 116 degrees. So this angle right here is 116 degrees. So we're going back to inscribed, but now we're going to talk about an inscribed quadrilateral. So a quadrilateral can be inscribed, because they don't all inscribe, but it can be inscribed if and only if its opposite angles are supplementary. So let's review. Supplementary means two angles that add up to 180 degrees, so we know we're going to be adding to 180 degrees. And if and only if makes this go backwards and forwards. If you know it's inscribed, then they can come up with supplementary. You could go backwards. If you can come up with supplementary, then you can tell me if it's inscribed. We're just going to go the one direction today. How do I know this is even considered inscribed? Inscribed, like an inscribed angle, means every vertex is on the circle. And for this theorem to work, the opposite angles, so angle A and angle C, must be supplementary, and the other set of opposite angles, D and E, must also be supplementary. Oh, good grief. So it's not just one pair, it's both. So here's our example. It says solve for x and or y. I think both of them have an x and a y, so it's probably just say and. So it's a quadrilateral. It's inscribed because every vertex is on the circle. So that means 72 is not equal to 9y. I'm about ready to make a gigantic mistake. 72 plus 9y should be 180 degrees. These are not congruent because we don't know if this is a parallelogram. We only know it has 4 sides. So the opposite angles are supplementary. So we're going to take 72 from 180, and we're going to get 108. So y would be 12. How about x? Again, here's the opposite ones. Again, I can't say x is equal to 90 right away. I can say x plus 90 is 180 because I know it's a quadrilateral. I don't know it's a parallelogram. So x turns out to be 90 degrees, which is nice. And last but not least is a little more complicated, but don't get concerned about the fact you have all those x's and y's, because the opposite ones are x's and the second set of opposite angles are y's. 5x plus 7x equals 180 degrees. Since this quadrilateral is inscribed, its opposite angles are supplementary. So 12x equals 180. So x equals 15. Same for the y's. 17y plus 19y equals 180 degrees. 36y equals 180 degrees, so y is 5. Let me put that back so you can see all of it at the same time. So one more time. Since this quadrilateral is inscribed, the opposite angles are supplementary. The opposite angles add up to 180. Now I'm going to do an informal proof. I know we've done the examples, but some of you are still going, why aren't they equal? Why are they supplementary? First, we don't know if it's a parallelogram. That's when the opposite angles would definitely be congruent. We just know it has 4 sides. So what you will notice is that angle E here intercepts this much of the circle. We notice that angle D intercepts the rest. So together they intercept all 360. But if it's an inscribed angle, it's really only half of what it's intercepting. So if they together are intercepting 360, then they together are only doing half of 360, which is 180. So opposite angles are supplementary, not congruent, in the case of an inscribed quadrilateral.